Hi, I'm Phil Day, and I'm the Director of Engineering at Configure Things. And in this video, I'm going to give you an introduction to the Configure Things platform. At Configure Things, we build all of our solutions as declarative systems. A declarative system is one where the user gets to describe the outcome that they want. And the system then takes that description, compares it to the current state, and then makes the required changes to achieve that outcome. Now, when they're properly implemented, declarative systems are very simple to interact with, they're robust, and they're very easy to reason about from a security and an audit perspective. Now, to explain why that's so, I'm going to pick an example that I'm sure we're all familiar with. Imagine that I need you to drive somewhere, and I've got the choice between giving you a procedural way to do it, a set of detailed directions, or in a declarative way, just giving you the address that I want you to get to. If I was going to give you the directions, then I have to know where you're starting from. And if I want to cover a range of different start states, I have to come up with different sets of directions for each of them. And if something unexpected happens and you need to divert, then you're going to need a different set of instructions to help you get back on track. And then finally, if something changes, and actually what I now need is for you to go somewhere else, then I've got to wait for you to get to some known point, some known state, maybe the first destination, before I can even give you the new directions. Now, in the declarative world, I would just give you the address and you put that into the sat-nav. And that acts as your declarative system and helps you get directly to that address. So great, it's easy to work with, but why does that help with robustness and security and audit? Well, keeping the analogy going, imagine that actually there are several people that need to interrupt your journey and each of them's able to give you different higher priority destinations to go to. And then all of those new directions, those new instructions are going to arrive at the same time. And this is the kind of complexity we actually see in complex distributed systems with several different stakeholders. So even if you're good at filtering out all but the highest priority set of new directions you've been given, the more different directions you're getting, the bigger the chance of missing one or getting some unexpected combination that makes you end up in the wrong place. And then when we want to work out why that had happened, when we want to audit what's happened here, I've got to look back through all of those directions and work out which particular sequence was it that caused the problem. And that's quite a complicated thing to do. If, on the other hand, all you'd received was a set of different destinations from different people, it's pretty easy to audit and work out which of those you were following at the time that led to the current state. And then when you think about validation, if one of those people is actually only allowed to send you to an address in some particular town, that's pretty complicated to validate from the list of directions that they've given you. But if what they give you is the address, it's a fairly easy state. So declarative systems are easy to work with. They're robust because we actually have a simpler set of interfaces, and they're easy to reason about from the security and the audit perspective because actually we only allow people to express a limited set of things rather than the full range of things you might get in a set of directions. So why aren't there more declarative systems out there? Well, we actually believe there should be. There are some. We've seen them come up particularly in the cloud configuration space, things like Terraform. Kubernetes itself can be driven in a declarative way. But of course, just because something's easy to use doesn't actually make it easy to develop. And there's a tendency from programmers to want to expose all of the features of their platform as a series of API and push the problem of what order to call them on into the next level up. And that's what leads to all the complexity and all the issues around error recovery, etc. So this is why at Configured Things we've developed a platform that consists of really three parts. There's a language for describing and capturing the state that you want to get into. There's a runtime environment for actually managing that model, and in particular managing changes that need to be made to it from the different stakeholders. And finally, there's a set of components that go with that let us turn all of that into a secure distributed system. So the first of those elements is the language. Our modeling language it's a JSON-like syntax, but it's got a number of features that extend JSON to support the kind of complexity that you actually need to have when you're trying to describe real-world situations. So as well as the standard JSON kind of declarative way of describing things, we have the ability to explain how different parts of that model should be merged together. We have the ability to make references from one part of the model to another and resolve those dynamically as we need to. We have a concept called lazy evaluations, which we'll go into more detail when we a session talking specifically about the language, but that lets us defer the evaluation of some of those references until a time when they actually can be resolved. And then we have expressions and templates, the kind of things you'd expect to find in a programming language. Now, it turns out that this language is actually so powerful that we don't just use it to describe the declarative model at runtime in the system. We actually use it to describe the deployment of our platform itself, in terms of which software components need to be deployed, how they relate to each other, etc. The second core element of our platform is the runtime system for managing the models, and in particular managing the changes to them. So other declarative systems that are out there will typically use a document format like JSON or YAML to describe the required state. And they'll let you make changes to that, but the changes themselves are then kind of forgotten. And if you wanted to reverse a change, you have to apply the opposite change to it. So you've still got this kind of declarative state at the middle, but you're focused on managing that model. What's different in our approach is we actually manage the changes as the first order objects. And we recognize there that the changes can make incrementable, possibly overlapping deltas to some part of the model. They can be coming from multiple independent sources, and they can be added and removed in any order. And this in particular gives a very, very powerful paradigm for being able to not just recover to some previous state, but in some cases be able to recover to an entirely different state if one change no longer needs to be made. And that's the reality that you see in many kind of distributed systems where you've got all these different actors that are applying and removing changes the whole time. We can constrain where those changes are allowed to be made in the model. So we can allow different people to make changes, but in some constrained space of the overall model. And of course, we can authenticate who's making the changes. We can verify the change itself to make sure it's valid before we put it into the system. And uniquely, because we take the changes in as documents, the documents themselves can actually be signed. And so we can verify and carry the authentication and the authorization of a change all the way into the system, rather than that being something that's just applied at the edge when the request is actually made. And then typically a system that we build won't just be a single model. It'll actually be a collection of specialized models, and those models themselves may be supplying small changes out to other parts of the system. Now, supporting the model manager, we have a number of other components that can be deployed to build up the full system. We have, for example, WebSocket servers handling secure communication. We have a display management system that we can use with smart screens or with dumb devices. We call this Web Windows. And that lets you build a situational awareness system where the content and the format and layout of each screen is defined in a declarative way and changed in a declarative way to give you very rapid reconfiguration of the displays as you need to as the situation evolves. And we have a number of other things, a notification system, model loaders for getting the changes into and out of the system, etc. So hopefully that's given you a brief overview of what the platform's about and why we've built our platform and why we feel so passionate about declarative systems. If you want to read more, please do go to our website or get in touch as getconfigured@configuredthings.com.